Am I audible to everyone?
Yes, sir.
And we have completed up to group by, if I'm not wrong. So we're going to start from here, right? So concat and append. Let's take, we have three data frames here. df1, df2, and df3. Right? We have the same column names if you observe all the data frames. Below bed, also. This is just dummy data. Don't expect that it's real kind of dummy data to explain the concept, hypothetical data. And index are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Basically, we can convert, we can combine all this into one, right? One top of another with the same column names, of course. We can do that using pd.append. Maybe you can say df1.append, df2, df3. It's actually df1.append. It's true. Right? pd.append, df1, df2, df3. It has no attribute. Oh, looks like they completely removed this. Yeah, they completely removed in the latest version. So we need to go with concat df1, df2, df3, and we got this output. Okay, I think ignore this part. They removed in the latest version. So focus on concat. This is what it does, right? So by default, this is axis equal to 0. Because you got the same output. If it is axis equal to 1, it is going to give me an output like this. Can someone explain why we got this? So you can see that there is one block here. It's df1, this is df2, and this is df3. The remaining places you can see that it has filled with NaNs. Why do you think it has happened when we go with x equal to 1? X equal to 1 means adding one next to another, like column wise.
Because of the index and column, right?
Exactly. So its index is 1, 2, 3, 4 for data frame 1. But in order to place one next to this, if you want df2 here, then the index is totally different, right? 1, 6, 7, 8. So there is no way that it can place df2 here. It has to place it here. So only then the index will come appropriately. The same way for df3 also. The remaining place anyway, wherever it is blank, it's going to fill with null value. That is why we got a lot of NaNs here. If the index is different, for example, in this case, I'm going to take the same index, 1, 2, 3, 4. I'm going to replace this one with this one. The same index. Now, if I go with axis equal to 0, you can see 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, whereas axis equal to 1, it is one next to another. Because we have the same index, it can very well place one next to another, even though the columns names are similar, same. Right? Any questions? This is when we want to combine multiple data frames.
So do we have to rename the indexes while we are doing like
no
row
need,
wise?
no need, but we can go whatever the way we got. But in some case, if you feel that the index is not something that you have to focus and need to get data one next to another, then you can copy and paste the same set of indexes. Or you can stick with default index so that it will anyway, come one next to another, right? but it's not must. It all depends on how you want the data. So that's all. Sorry, where is that? Any other questions on concat and append? Leave about append. It's concatenation. All right, the next one is very important. Focus on this. You might have heard SQL joins, right? In pandas, we call join as merge. Okay, so here I'm going to take two data frames. So merge in SQL Server or merge, I don't know whether it's there or not in Oracle. It's totally different. The concept is totally different. Whereas in this case, as per pandas, merge means nothing but to join. SQL equivalent to join. Okay. So I'm going to have two data frames here, movies or revenue. So we have two data frames here. One data frame that is going to give the list of the movie names, and it has its own ID 1, 2, 3, 5. 4 is missing in this, right? 1, 2, 3, and 5. And revenue, we have it's basically the continental revenue, the basically revenue based on continent, categories based on content, and it has its own ID. 1, 2, 3, 5 here, 1, 2, 3, 4 here, 5 is missing here, but we have 4. What does that mean? We have Avengers 1 here in the movies data frame, but Avengers on the ID is same, isn't it? Avengers, based on the ID, we need to judge. So for this Avengers 1, an American region, they got 98 million, whereas in Asian region, they got only 78 million. Kind of like that. So we can read the data in this way, or else we can combine these two into one. We can join these into one. We call this joining operation in pandas as merging. The way we can do that is pandas merge and then movies revenue, right? And the order matters again. Okay, I'll explain why the order matters and how it is inner join only when the ID matches. Here we have 1, 2, 3, 5. Here we have 1, 2, 3, 4. 4 is missing in this, and 5 is missing in this compared to this one. And what are those IDs that are matching here?
1, 2, 3.
Only 1, 2, 3 is matching. The remaining IDs are not matching. 4 and 5 will get skipped if you use inner. So we have other options too, but we will see that later. So on which ID is the common column that we have to join? I mean, use it for joining. It
ID.
is ID column. So in the case, and again, it's case sensitive, so you need to be careful. So it's always better cross-check movies dot columns. So I'm sure that it is small I, small d. I'm going to go with this one. You can see that we got where the ID matches. So how does it know that it has to match the ID? This is the way that we have to mention on equal to ID, and it has to be common in both. And inner is the join. So you can see that only matching IDs I have to get. And movies and revenue, you can see that ID, name, America, and Asia. I got all the columns appropriately, right? Instead of cross-checking one data frame next to another, I mean, keeping one data frame next to another and checking it, you got one data frame as a whole now. So any questions on this?
Sir, if the column names are different, let's say
Yeah,
the value should be different.
There is another case for it. I'll explain that. So is this part is clear?
If the index is different, will it matter? Of course, we are using ID, but
No, if index is different, it doesn't matter. In fact, it's the default index. We don't have any index as such. We can completely ignore that index column if at all it is been part of list of columns. Right now, this default index. We have to we can specifically mention the ID column and we can exclude the particular column, right? Fine. Any questions on this? The next one is, what if we don't mention this? If we check the documentation, shift tab, it's what is how here, what is the default option here? Inner. So by default, how is internal? What I will try to exclude this and see whether it works or not. The same output. So how equal to inner join, wherein it's going to give us only the matching IDs, matching on column. Here the matching on column is ID. and we get, and even if you don't mention it, it's enough. Still, it's always better to go with this one, that it will improve the readability. Okay, even if you don't mention this is going to work. And what if I miss the, completely skip this one? Let's see whether it works or not. It still works, because as long as it has a matching column, it's going to work. As long as it has matching column. What if it doesn't contain matching columns? For example, I'm going to take these two data frames. I'm going to replace this. Here it's movie is the same thing. If you observe it closely, the ID is not ID, it's ID underscore. I intentionally add this suffix, a postfix, ID underscore one, right? Now, if I go with all the defaults, and let me skip, remove this part. If I go with all the defaults, what it says? It says that no common columns to perform merge on. Merge operations left on, right on, okay, whatever. But it's saying that there is no common column. Then in that case, what we can do is left on. What is, again, the reason why I said order matters when I mentioned this data frames is, this is going to the left data frame and this is going to the right data frame. So when I say left on, I need to look for the left data frame. What is the column that I want to match with? ID, right? So ID, and right on, what is the column name? ID underscore 1. Of course, the how is basically is inner by default. It's going to give the same output. Got it? Any questions?
No.
All right. The next one is, we have seen left on, right on. All right. There are a few other options here. So it's not just inner. I will do one thing. So I will take this output as a record. I'm going to make it another one. So compare the output of this to that of whatever I'm going to show it here. So it's actually left, right, and full. Sorry, it's not the parameter is not full, it's outer, if I'm not wrong. Yeah. So can someone tell me the difference between these? Just by the names, you can see, if you follow the names, you can easily interpret it. Inner is going to give the common columns, right? Common values based on the column you provide on condition. Whereas the left is going to, what it does? What do you think that it is different from?
It will give all the values of movies and only the column common of the revenue.
The reason why it is going to give all the rows of, not all the columns, all the rows of
Yeah, rows.
left table.
Left.
Yeah, whereas we don't have anything that is matching for 5, right? So it's going to give the null values. The reason why when we mention left is going to fetch only values from movies, because the order matters, as I said before, movie is going to consider as left and revenue is going to consider as right. The same way, right, if you look at it, there are some rows that are not part of left table, right? If you look at this, we got table from right table that has the ID with 4, whereas for the ID 4, we don't have any data in the left table. So it came up with null values. The same way, outer is nothing but full outer join. We can see that you got all the common values. Apart from it, you got what? You got from the right table and the left table also. Of course, if it doesn't contain any records matching with that with another frame, data frame, obviously it's going to get null values. It's basically like inner join, inner join, right join, and left join. It's going to be a combination of all. Right? Any questions on this?
No.
No.
Of course, if you don't require one of these columns and you want to stick with the ID only, then you can easily filter it out. You can say that I don't require this. So go with no this one. So that it's going to be much cleaner, right? Fine. So what else we have here? Okay, so this is another interesting case. We have two data frames, movies, revenue. Here we have ID, but only addition to the previous data frames is year part, isn't it? So now we know how to join. So let me take the inner join part. Here it's ID, same column name. So we don't really require left on, right on. You can simply stick to ID, right? Sorry, I forgot this comma. Or how inner is also a default one. But if you want to match, if you want to join not just on one column, but you want to join on both the columns. For example, here we have 1 2015, right? Here again 1 2015, 2 2016, 2 2016 we have combination, 3 2017, 3 2000. Oh, I think I have taken it wrongly. Maybe what I can do is 3, I'll take is 2018. Then it makes more sense. I have taken 3 2018, but here we have 3 2017 and 4 2019, 5 of course it doesn't match. But as I'm going in, it has to get the same ID, right? Wherever it matches. Up to here it's fine. What if I want to match both ID and year? Then I have to mention the list. Whenever it asks for more than one column, it usually be like this. You can see that ID and column. You can see that 3 we haven't got because 3 2017, 3 2018 doesn't match. It's going to check both the values. The combination should be unique. Only when combination matches that particular set of rows we get it here. Got it? Any questions on this?
So like that with on we can use n number of columns, right? Is there any limitation?
No, you can use a number of columns, but
Matching data should be there.
the question is why we need it. So if you have such context, if you have such a requirement, go for it.
Yeah. Okay.
All right, so the same way we can, it's not just inner, we can even go with outer to join, left. So you can always apply, right? Fine. I think that's it on merge. So if you have any questions related to merge, let me know. All right, and the next one is stacking. I have a data frame here. Movies, you can see that we have movies. I'll show you the output first. Stack. And of course, it doesn't make much no. Let me reset the index. It's actually a series. So can someone guess what exactly it does and why we need it? Those who have some amount of data analysis exposure, so they can easily guess it. Or else I will explain it, don't worry. So just try to give a guess. What do you think has happened? And why we may need this sort of data? This is the data. You have part 1, part 2, part 3, and so on and so forth. Here it got really the name, but it got it in this form. Any guesses?
S- Suppose if we want, what is the data present in that column? I mean, something like
First of all,
definitely
first of all, get into the structure first, and then we'll get into the purpose later. So,
okay,
what
how
exactly
many
has happened?
number of columns will be there, right? That many times each row will be repeated.
Basically, the columns being reflected as the kind of row.
It is
Yeah.
transposed to.
Not exactly transpose. Transpose is like, yeah, columns into rows and rows into columns. But even you can look at the index, the rows, part one, part two, it got reflected in this one, isn't it?
Yes, sir. Yes.
So basically, what has happened here is that all the year and name got reflected here. So in this case, what happens is like part one and the year 2014, right? Year 2014, and the name, movie name is Avengers 1. Whereas in this case, part one year 2014, part one name Avengers 1. So instead of like this part one name Avengers 1, part one year 2014, if instead of checking like this, part one, part four name Avengers 4, instead of checking like this, we get in rows form. So they can easily cross check it. The question is, why do we even need it? So there are two kinds of databases you will find. One is OLTP, OLAP. Have you heard about this? Have you heard about acid properties?
Yes, sir. In database, we have to read that.
Right. So there are two kinds of database you see. The online transaction processing for regular transactions like insert, update, delete. Of course, select operation. Of course, selecting is nothing but reading. Whereas online analytical processing is only for reading. That is select operations. Only for reading. So for insert, update, and delete, data should not have redundancy. There should not be any repetition. That is why we follow the CF chord rules. First normalization, second normalization, third normalizations. Those normalizations we will follow and make sure that the data set is going to be in a form that is not repetitive. Whereas when we go with reporting, the problem is that it has to do a lot of work to make it in a way that user can easily read it. Obviously, there will be a question whether how come this is going to be helpful, right? So if you look at this tree view, the reports are going to be mostly tree view, isn't it? Going to be like this. Maybe this is a much better thing. You can see that. And when you click, when we go deeper and deeper, you get more and more information. When you are at the top level, it's going to aggregate information. Suppose this this employee, let's take this company got profit in 1910, 19, let's take 1990, some let's 20 million, 2030 million. Whereas if you don't expand this and shrink it down to shrink down this one, what happens is this 20 plus 30, 50 million. The aggregate information will display here. So if when you click on this, it's going to give on year-to-year basis. So if you need data in this form, then you need to apply methods like stacking and all. So this is more for reporting, even though it doesn't make much sense. If you present this data in tree view form like this, what happens is when you click on part one, it's going to expand year name. When you click on year, it's going to give the year. When you click on name, it's going to give the Avengers name of that. Got it? So in order to meet the needs of reporting, online analytical processing, OLAP database kind of databases, we need to convert this online transaction processing databases, data frames or database or tables or whatever, into this one. Any questions on this part?
Yes.
All right, so if you want to unstack this, I'm going to, we should not reset it, let's take, and I want it in the form of series. If you stack, right? we got this one. So if we unstack this, it's going to get it in the form of like the way it used to be. This data got converted back to original form. Okay. So unstack is exact opposite to stack, but if we apply it on reset index bar, it doesn't work. After applying it, you can see that it may give unintended something that you can't expect. I don't know if this works or not. Let me stack is the data frame. It doesn't work. All right. So any questions on stacking and unstacking? The whole idea is OLTP and OLAP. If you understand these two, then it's quite easy. Reporting is different. Normal transaction like banking data sets or any data sets, you can see that most of the database are transaction processing. But if you get some kind of reports, mostly from OLAP databases. We can directly generate reports from transaction databases, but that requires a lot of additional processing power. It has to convert this data set into a required form, right? It has to do a lot of processing. So in order to reduce the processing power, if you have a lot of RAM and reportings need to be quick, then we apply these sort of things. Okay. Next one is pivoting. Let me take movies and revenue. Like the way we merge, we need both movie revenue data frame. So I'm going to do movies revenue. I'm going to go with the default one. Anyway, it has on equal to ID, how equal to so movie revenue. So got it. Now again we have transactional kind of, but if you want to convert into multi-dimensional, so we call this as multi-dimensional. Tree view as multi-dimensional. So this is one dimension, this is two dimensional, and this three dimensional. So more and more depth you go, so more dimension is going to be. For example, in this case, it is 200. Actually, this level it is one dimension, and this is two level, second level, two dimensions. If you look at this one, this is one dimension, this two dimension, and this three dimension, fourth dimension. The more and more deeper you go, more dimensions you have to consider it. Suppose if I have a data frame like this, like it's transactional process, OLTP kind of table, and we want to convert into multi-dimension, we can do that. But pivot in using Python is not really as efficient as we have it in Excel, Power BI, and Tableau. So Jupyter Notebook or Python libraries are not really not kind of tools, right? They're not tools; they are libraries. But the kind of visualization that you get in Power BI and Tableau are much more advanced. So don't compare the output that you can see it in Power BI and Tableau or even Excel to that of what you get in Python. But we can do pivoting here too. So this movie revenue, I'm going to apply pivot, but we need three things: index, columns, and values. Values are nothing but revenue. Here the revenue is America and Asia, right? Let's start with that. Value is America and Asia. So those are measures we call it as. Measures should come here. And then columns, what will be the columns here? So it's the name, right? Name here. And is it name that we need to be okay? Yeah, column should be name. And index should be, I'm going to go with index. Yeah, so this is better. Now you can see that instead of this, what happens here is Avengers 1 got 98 million in American region. So in this case, we need to keep checking it. Let's take, so there clear segregation between America and Asia on for each of these movies, right? Avengers 1, America 98. Avengers 1, Asia, sorry, Avengers 2, Asia, it is 96. So we need to cross check these two and get the output. Whereas in this case, we have only 3 rows, that's fine. But if you have too many, then this will be much better way to do that. And this is again for reporting. You can see that Avengers 1 directly we got American region, we can straight away get to this block. For Asia, this one, Avengers 1, 78. Avengers 2, 96 million. So Avengers 3, 32. So it's quite easy to read the data. So that is the reason we have to have a clear segregation between transactional processing database or tables to that of reading, reporting or tables that are only for reading. Okay, so did you get this point? Let's take in this case, I can even take year, but the only confusion is which year it is pointing to. So I will do one thing. I will drop year Y. That's equal to 1. I don't require it, right? So we got year X. So I will do one thing. So I will rename the year Y, the year X, to just year. But I need to wrap this in curly brackets, as the dictionary. So it's going to get renamed. But again, this renaming also across by default it's across rows. We need to do it in across columns. Now this is much better. So if I go with this one now, it works. The year is this, and 2015 American region I got American region Avengers 1 got released and 98. That's how we read it. That's how pivot works. It's basically multi-dimensional. Again, in reporting tools, you can see that when you click on this America, you get this whole range. Or else it's going to be shrink down to 1. So basically, what does that mean? The America, it's going to be 98 plus 67 plus 86. The whole summation, we see that. We can even apply mean and other aggregate functions, but usually it's going to be summation. When you click on this, it's going to get expanded. Otherwise, if when we don't click on this, 78 plus 96 plus 52 will get displayed. That is summation will get displayed as one value.
So in which topic we are going to see those? The concept you are telling.
It's for reporting. So we don't use it for reporting, but because the Python we should not be use it for reporting. If at all you need a dedicated tool for reporting, then go with the Tableau or Power BI. But in some case, you want to see the data for your own purpose, and just to understand it, so that you can take it further. Then these libraries are going to be, these methods are going to be very handy. But these are really not for reporting. It's only for to understand the data. There are a good number of tools that are only for data visualization. You need to pick those tools rather than this. But these are free. Power BI and Tableau are quite expensive in terms of licensing.
Yeah.
Yeah. Any other questions? There is another one called pivot table. I will show you that. So it is going to do the same thing, no change. You can see that it's giving the same output. But there is a subtle difference between pivot and pivot table. In the case of pivot, I have given refer this one. We have really given the points where it matches and where it doesn't. Pivot table only allow numerical types as values, whereas pivot does not encourage duplicates. Let me explain what is this mean. So as a pivot table will only allow numerical types as values, right? Here, in fact, what are those values? Revenue, American, Asia, but all these are numbers. All these are numbers. What if I try to insert some string? Okay, 67. Okay, so I'm going to do that. Now you can see 67. What if I execute pivot? It works, 67. What about pivot table? It is giving me an error. What does that mean? The pivot table does not, you can the aggregate function fail. So pivot table does not accept values that are non-numerical type. Okay. So, but pivot accepts, pivot table does not. I'm trying to explain the difference between pivot and pivot table. Okay, I'm going to go back with the same value 67, and of course it works. Any questions on this? Another point I want to bring it on. So is this clear? Pivot table does not accept values, whatever the columns that we have under values, which has non-numerical type. Only when these columns has numerical type, it could be in integers, floats, then only then it will work. If it has strings kind of or complex numbers, then it's not going to work. But pivot does. Another thing is pivot does not accept duplicates, whereas pivot table accepts duplicates. I will try to create a duplicate table. So I mean to say, so let's take that. I think here I will try to make it 3, and I'll make it as 2017. So it is going to get repeated. Let's see whether it has any repetitions. No. Again, it's going to, let me repair this. Now you see there are a few repetitions, right? Avengers 2, 3, 2086, duplicate row, I don't know. You can see pivot started throwing error. Because it has some duplicate, Indian content duplicate rows. Whereas pivot table, I didn't face any issues. Wherever it matches, it is giving me the output. You see the difference? So if you are still confused, try with what I did. Pivot table will accept only numerical types in the case of values, whatever the columns that you provide under values, it has to have numerical type data. If it has non-numerical data, it's going to throw error. Whereas pivot has its own limitations in a way that if the original data frame has any duplicate rows, then pivot does not encourage duplicates. Whereas pivot table does accept duplicate rows, duplicate data. Is this clear? Any questions?
No, sir.
All right, it's anyway, we still have 20 minutes. I would like to continue tomorrow. So we'll see, we'll stop right here. We'll continue tomorrow and we'll start from mult. Right, so we'll start with mult and then we will keep going on and we'll complete up to here tomorrow. Right? Right. That's it for
Okay, sir.
today. Yeah. Thanks for joining.
Thank you, sir.
Thanks.